So suppose you suspect that the exchange rate changes might be affected by past exchange rate changes as well. So in that case, you might what you can do is to create a lag variables for the exchange rate changes and then include it into the regression model. So before we create such lag variables, let's have a look on the data frame. We can see that and we're going to create a lag variables for the dependent variable, which is the s underscore change underscore Aussie, and how we're going to extract this column from the first observation to the second last observation, and then we're going to concatenate it with NA as the first element because we want to create a lag variables, right? So we don't have the data before the 1970 first quarter. So what we can do is simply give an NA missing value, and we would like to exclude the last observations for this column. So we are going to name this newly columns to be lag underscore s underscore ch underscore Aussie, and then if you check it again, it's exactly what we want. So we have the lag variable as a regressor now, and we're going to include this third explanatory variables as the on the after the on the right hand side of the tilde as well. So we're going to create a second LM object and name it as for instance m underscore 2. And if you run summary again, you can see that now the regression output have the now we have a different regression output. So suppose we would like to test whether the carryover impact is significant or not. So again, we're going to save the output of the summary on the LM functions, and then we're going to, because we are explicitly want to test whether the carryover impact is significant or not, right? So we're going to, in other words, we're going to test whether the null hypothesis that the beta 3 is equal to 0 against the alternative, the beta 3 is not equal to 0. So because the hypothesized value is 0, so we could simply use the t value, which is the fourth column, third row. I mean, fourth row, third column. Sorry. And then we're going to use the pt functions. And if it is CO2 or CO3, you may use p norm and without degrees of freedoms. So it's a two-tailed test, and then we times 2, and then you can see that the p-value is 26%, which is greater than 5% significance level. So we cannot reject the null hypothesis that there are no carryover effect. And alternatively, again, like we can use linear hypothesis functions by providing the first argument, and because this is the extended model, right? The extended model is m underscore 2, and we're going to test whether the carryover, the lag variables is equal to 0, the effect, and you verified from the p-value. Yeah. So of course, like you could use the f statistic directly to get the p-value, but it should be the same.